Welcome to the AGUA Automated Geospatial Watershed Assessment Tool video series. AGUA was developed by the University of Arizona with the USDA ARS Southwest Watershed Research Center and the US EPA. AGUA is available at www.tucson.ars.ag.gov/agua. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the 6th video in this series, Prepare Precipitation Data for the KINEROS2 Hydrologic Model for the Andreas Canyon Watershed. To prepare the precipitation data for KINEROS2, go to AGUA Tools, Precipitation Options, write KINEROS Precipitation. KINEROS is designed to use rainfall events that specify the rainfall depth and duration. AGUA provides 4 ways to obtain these data and create the rainfall files for use in KINEROS2. You can obtain data from the NOAA precipitation frequency maps available from their data server. AGUA includes a design storm database in the AGUA Data Files directory. You can provide your own depth and duration from any source, or you can provide a hyetograph with rainfall intensity over time. These data are usually not readily available, so we won't go over this method. We'll review how to create the precipitation file for the first 3 methods. First, we'll look at the user-defined depth method. Go to AGUA Tools, Precipitation Options, write KINEROS Precipitation. Select the discretization you created previously. Then select the storm source from the drop-down menu, User Defined Depth. Enter 32.02 millimeters for a 10-year, 1-hour design storm. This is about 1.26 inches and is from the NOAA Point Precipitation Frequency Estimates, and represents a typical monsoon storm for the mountain fire area. Next, enter 5 for a 5-minute time step. Select the SCS Type 2 storm shape distribution, which is typical for most of the U.S. Leave the initial soil moisture at 0.2 to represent a mostly dry condition. For the storm location, we'll apply the storm to the entire watershed. AGUA provides the option to identify a storm center, but since we'll be looking at land cover change from the fire, we'll want the rainfall to be evenly distributed across the entire watershed. Name the file 10-year, 1-hour, and click Write. Click Yes to confirm the file was written and close the form. Next, we'll look at how to create a design storm from the ASCII grid from the NOAA Precipitation Frequency Data Server. This is a multi-step process and is more complicated than the user-defined method. First, we'll need to download the grid for our design storm from the NOAA website. Notice that you'll be downloading the data as a zipped ASCII grid with the associated metadata that includes information on projection and resolution. Scroll down the page to the pull-down menus and select Volume 1 Semi-Arid Southwest. Select the data type, Precipitation Frequency Estimates. The other options refer to confidence limits, but we use the actual precipitation frequency data. Select the series as partial duration series, which are based on all events during the period of record and are used to determine the return periods. The other option is the annual maximum series, which we won't be using. Next, select the average recurrence interval as 10-year and the duration as 60 minutes. Click on the Click Here to Begin Download button to download the zipped ASCII file. Unzip the file and add the ASCII raster to your map. This is a raster layer of the southwest U.S. and has precipitation estimates in inches times 1,000. AGUA will automatically divide these values by 1,000 and multiply them by 25.4 to convert to millimeters, which is required for KINEROS2. Next, project this raster from decimal degrees to UTM Zone 11 and NAD 83 datum, the same projection as the other data used in the tutorial. Name the new map SW 10-year 60-meter UTM to indicate that it's projected data. Now that we've prepared the NOAA precipitation data layer, we can create the design storm for KINEROS2. Open the KINEROS precipitation form by going to AGUA Tools, Precipitation Options, write KINEROS precipitation. In the form that opens, select the discretization you created previously. And for the storm source, use the drop-down menu to select NOAA. Select the precipitation frequency raster you just projected, SW 10-year 60M UTM. Then fill out the rest of the form as you did before for a 1-hour duration storm with 5-minute time steps, an SCS Type 2 storm distribution, 0.2 initial soil moisture, and apply the storm to the entire watershed. Name the file so you know it's the NOAA data, 10-year, 1-hour, NOAA. Click Write and then Yes to confirm the file was written. The last method to create KINEROS precipitation data is by using the AGUA Design Storm database. This database includes design storms for several locations: the San Pedro River Basin in Arizona, Clark County, Las Vegas, Nevada, Santa Barbara, California, and Manassas, Virginia, near Washington, D.C. The database includes the typical return periods and durations for each location. These data were obtained from the NOAA Precipitation Frequency Database and are also available in tabular format. You can add your own locations to this database if you have this information. First, add the database to your map. Go to AGUA /data files /precip folder and select dsgnstrm.dbf, the Design Storm database. Open the KINEROS precipitation form and select database from the drop-down menu for the storm source. Select the database you just added to your map, dsgnstrm.dbf. Then select a location. We'll use Clark County, LV, since this is the closest location to the mountain fire near Palm Springs in the database. Proceed the same as before with a 10-year 1-hour storm, a 5-minute time step, the SCS Type 2 storm distribution, 0.2 initial soil moisture, and applied to the entire watershed. Name your file so you know it's from the database, 10-year 1-hour DB. Click Write, then Yes to confirm the file was written. Now look at the precipitation files we just created from these 3 methods. These files are located in your workspace folder under the tutorial_mountain fire Andreas Canyon folder, in the discretization folder, and then in the precip folder. First, we'll look at the 10-year 1-hour.pre file for the user-defined storm depth. Notice that AGUA creates a header that documents how this storm was created, including the storm depth and how the hyetograph was computed. Every precip file is formatted as if it was from a rain gauge, where the X and Y values are the rain gauge coordinates. The SAT is the initial soil saturation, N is the number of time steps, and finally, the time depth pairs are shown in millimeters. Notice that there are 13 time steps, N equals 13. Next, look at the precipitation file created using the NOAA raster. It has the same format, but the total depth is a bit different, although the rainfall distribution is similar since we use the SCS Type 2 method again. Finally, look at the file from the Design Storm database. The total depth for a 10-year 1-hour storm in Las Vegas is slightly less than from the other methods, but again, the distribution follows the same pattern. The next video will demonstrate how to write the KINEROS2 input files and run the model for the pre-fire conditions.